Hey everyone, I wanted to give back the applause to the enormous and gorgeous organization of this event. I think it's in order to have a little applause for everything involved here, all the text and stuff. Thanks a lot for being here. I'm really excited. Yeah, my name is Julie Christian Platzer. So it's pronounced Willhaben, which is, if you would translate it in English, something like, I want to have this, wanna have. Yeah, it's a term used. And we are Austria's largest classified site, classified as in terms of Craigslist and not top secret. And we are also one of Austria's largest sites as such. So we are top in Austria in terms of page requests and page impressions, which is kind of a contradiction. Austria is not a big country, but we are a large site. So I give you some numbers, and you can decide if we are a large company or not. All right, and my task today, during the next few minutes, is to guide you through some of our decisions. Unfortunately, the first talk today essentially did everything that we have running at our company. So I'm quite happy that I didn't divulge too detailed into our system setup. So I'm going to talk about some quirks, how we took the decision to go for HA-Prox in the first place, and how this could also affect some other companies. And I'm going to give you some examples of challenges that we had to face, and maybe you can get something out of it. All right, it all started in 2015, which still amazes me. I have to look up this date every time I do a presentation because it's just 4.5 years ago. And back then, we were running something like this. So maybe as a background, Willhaben is a startup company. So we started with very few people, and it grew over time, and now we have like 250 people, 250 employees, and yeah, you can imagine that there are a lot of challenges we had to tackle to put up with the growth. So back then, it was in the range of 600 to 800 megabits per second. This is a decent amount of traffic, but still, yeah, it's not that much, and 99% of it was HTTP. So we were solely delivering HTTP requests or responses, better said, except for login and payment. Yeah, and this was just 4.5 years ago. Now we are running HSTS on our platform, so there is no HTTP anymore. Yeah, we just had, like, of course, we had a load balancer at the time of an undisclosed name. We had just 4 pools, our web pool, one for the API, the desktop, and a caching image pool. So that was it, and we were really limited in operating these pools. We just had the ability to train them and disable them over the web front end. There was no API request for us because we are hosting, so we are not hosting the infrastructure ourselves. We start from operating system level up, and this also didn't change over time. Yeah, and it cost a lot, this undisclosed load balancer solution. Yeah, the first interesting thing I want to point out is our incentive. So you might think that our incentive to go for a software load balancer solution would be something like gaining flexibility and having the operators or SREs have an easier day, but that was not it. The incentive to have a look at our load balancing solution came with the need to go all in on HTTPS. So this was the major incentive. And at the time, the manager approached me and said, hey, maybe we could just, shop the next bigger F5. OK, now I said it. And I told him, yeah, we could, but it will cost a lot. And you've seen the numbers from the first presentation. It really costs a lot. And plus, we're not happy with it, because we still had would have to deal with this limited functionality that we need to put up with. So and this colleague of mine, let's call him Mr. O, he was all like, it's Linux, baby, we can do this on software. I didn't know HA Proxy at the time, but he is one of these tech guys constantly pushing for new solutions and stuff, and he said that we can pull it off. And in my opinion, I always thought that if something is done in hardware, then it has to be way better than software, because otherwise they would do it in software. So I was really skeptical about replacing something like an F5 with a software solution that I didn't even know at the time. But after some initial testing, yeah, I thought maybe we can pull it off. And we approached our manager, he gave his okay. Yeah, and that's how HA Proxy 1.5 came to pass. Our initial setup may look weird to you if you haven't used HA Proxy in the 1.5 version. So there was no multi-threading, it was all multi-processing. And so to give you a quick overview on what the design really does, we have like this bunch of front-end cores that essentially just do the HTTPS offloading, and then they really connect to the backends through localhost connections, really HTTP localhost connection with a proxy version 2 protocol. And from there, we go to the backends. And also the scaling is pretty much, or was pretty much, as you see there, we had these 2 backend processes. And funny thing is, with this kind of setup, we kind of emulated a hitless reload, because you could drain one backend, reconfigure it, put it up again, drain the second backend, configure it, and put it up again. And we usually didn't touch our front-end process because we only needed to touch it or reload it when we really needed a new IP, and that was not common case back in the days. So this worked pretty well. It was perfectly fine to deal with our 600 to 800 megabits per second. We always had core stickiness. That's something that we also decided to keep, even for the newer implementations, and we're pretty happy with it. Of course, when we first switched to DNS, there were some problems. We didn't account for the enormous amount of connections that would go over our backends if you keep it in keep alive mode. So we had to switch it to server closed there, but nothing that you couldn't get under control. Yeah, enough from that. Now I want to guide you through some of the challenges. This is a mostly time-based challenge line, so it's 5 challenges. Bandwidth, we were pretty sure that we had to deal with bandwidth in the first place, because all these HA proxy servers, which were, by the way, old ESX hosts that we used to do this, were perfectly fine with dealing with the traffic, but they only had bonded 1 gigabit interfaces, and yeah, we already were at 800 megabits per second peak, so we had to do something there. And since these pre-built systems all had like 6 NICs, we decided to go with IEEE 802.3 AD bond, which is a link aggregation essentially on OS level. But the thing is, this must also be configured on a switch where we didn't have access, and it turned out that this point was the caused most problems. Yeah, because our infrastructure provider, was challenged by it. Let's put it this way. Now we are running. So how did we solve this? We had this thing for some time. Now we are running everything in 10 gigabit interfaces, so everything is scaled up now, but at the time it was simply too expensive. And one problem that we ran into was something like that. Oh yeah, I think you can read it, or decipher it. So we had 4 of these interfaces connected into the link aggregation, and one of them was overloaded. So we hit the cap of one of the interfaces because at that time we only had 2 cache servers with 2 IPs, and chances so the bandwidth was not evenly distributed, and we saturated one of the links, which had some really weird effects. We thought that HA proxy might have a bug at first, but then we looked into it and saw, okay, this is something completely different. And this was also the cause why we decided to, not go for a link aggregation, let's see, lighthearted again. Because we are already hitting the 10 gig limit. No, we are not hitting it, but we're getting close to it, so we're still growing, and that's maybe something that we have to come up with in the future. The second challenge that we needed to tackle was going for multi-threading. Why? We wanted to get rid of multiple backends. First of all, for scalability, because it would be nicer to just spawn threads and don't care how many processes are actually running. We also have our configuration in Ansible, and theoretically it was no problem to scale the backends or the front ends. But there are health check issues, for instance. So if you're doing like we did, the front-end processes had to health check the back-end processes. And if you spawn another one, then the health check traffic multiplies. So there are a lot of good reasons for us to go to multiprocessing. And one of the major implications was that it was not strictly required for Kubernetes, but really wanted to have it for Kubernetes. Because in Kubernetes, you need an ingress controller, and it would be nice to just touch one configuration file there. So yeah, multi-threading is something that we really wanted. It worked flawlessly without HTTPS. So remember, we had HTTP on the backend side. So solely HTTP, and there we were running from version 1.8 without any issues. This was really nice, so now it's stable in 1.9 R1, but it proved to be challenging when we enabled HTTP2 or H2, challenging in terms of undesired behavior. But I'm going to get into detail what happened there at the later slide. Then we wanted to have Kubernetes. Kubernetes is cool. Everyone wants to use it. And there are certain requirements that you have to pull off in terms of what you need on your load balancing infrastructure to actually do that. One was the ingress controller. So you needed an ingress controller. We are not running HA proxy as a sidecar container within Kubernetes. This is bare metal. We have 2 machines, which are, actually they are active because we are, but consider it active standby with keep alive D between them. And we needed an ingress controller to actually do this. We also needed hitless reload because if you are dealing with Kubernetes, you will get a lot of configuration changes if there are a lot of deployments and you're thinking about continuous delivery, then you really need to have hitless reloads to do that. And also one thing that I really took care to have is a guaranteed syntax correctness. So at any point in time, I wanted to have a reloadable, restartable configuration at the host machines. You might think, how can it happen that it's not that way? So the solution for this problems is actually quite simple. So in HA proxy 1.9, hitless reloads were introduced. Yay! We immediately switched to 1.9. It was a good decision. And we finally were able to put everything in one process, have one configuration file where everything is there, and go for Kubernetes. In Kubernetes, we have a self-written ingress controller, so we are not on 2.0 yet, but it's definitely something we will have a look into. But until now, we're using a self-written ingress controller. It's also written in Go. Works pretty nice. but does not support everything you could do in a Kubernetes ingress itself. So there are certain things missing there. And we're using optional backends. What does this mean? So usually if you have a configuration, you have some IP address. We do it like this. There's an ACL, so we bind all the IP addresses in a list. It's not that many. You have an IP address. Hey, if the destination address is this, then use this backend K8s app. So if you just put it there, and the below configuration is generated. So we include 2 configuration files. One is the main configuration, one is the configuration provided by the ingress controller. And if you do it like this, and you simply use backend Kubernetes app, then, and someone decides to unexpose this service, then the backend is deleted, and you cannot reload XJProxy again or restart it again. It's because it's a syntax error, because you have a backend used that's not there. If you do it like this, it won't work. But everything else will work, and that's the thing that we go for. I don't know if there's a better solution, probably there is, but that's what we came up with. I don't know. Yeah, you know how it is. You have a problem, you find a solution, it works. You keep it that way. That's the way of the SRE. Yeah, challenge 4, second to last challenge that we had to tackle was we wanted to go for HD2. So HTTP 2.0 was really something that we had in mind of using. Of course, because it's more efficient. So for those of you who don't know much about it, the major difference is that there are way less connections from a client to a server, and multiple requests can be dealt with over a single TCP connection. So that's the major point here. And of course, it reduces latency because the TCP establishment, the TCP connection does not have to be established in the first place. So it's really efficient, and yeah, it's the future. So we really wanted to go for it. It had a huge impact in the TCP sessions that we had on our servers. And of course, we also wanted to be cool and have H2 enabled as fast as possible. And we did enable it. And it's essentially just, yeah, you put it in the right things in a JProxy, and JProxy does the magic for you. It's done. It's done. And we got all that we wanted, so now we were cool. We had less connections. Everything was really fine. But we also got some other things. For instance, these busy looping processes that were mostly connected to HTTP2 and HTTPS. So, and now really my kudos here to the JProxy Enterprise. So we are running Enterprise support team. The time that they took to really produce a fix for all these problems, it was really enormous how fast they were, so really perfect. We also had some seg faulting. Looks bad, but if you think about it, the busy looping is far worse, because usually, first of all, our prime time is not during working hours. So people get home from work and they scroll through our ads, and it's mainly in the evening, somewhere in the evening. And then we had our prime times, and all these problems were prone to happen during our prime times. So during high load scenarios, sometimes one of the connections just got stuck, and it essentially just took the resource of one of the processes. This by itself is something that will not pop up in some monitoring, because it's just a higher load. I mean, our load normally is in the range of 6 cores during rush hours, and then it was 7 cores. We do have a monitoring on the load there, and if more than one gets stuck, we get an alert and we can restart it. Yeah, but still, it can be pretty annoying. On the other hand, if the process seg faults, it stops, and it's immediately restarted. It's even, sometimes it was so fast that Keep Alive D was not failing one single health check in the time, so JProxy starts really fast, so that it produced a downtime of 1 to 3 seconds or something, which is still bad, but not that bad. So a segfault, in my opinion, is something that could live with easier. And then we also had some very strange behavior that I wanted to divulge into and give an overview. So we saw a lot of these lines, and with a lot, I mean like 40 to 60,000 a day, where apparently JProxy, so CD means the client aborted the connection and it was in the data phase. So the client sent the request, everything was okay, header or everything. JProxy directed it to the back end, started receiving the answer, and then cut the connection. Okay. We also did a TCP dump, and it was just like that. JProxy sent the reset packet. We didn't, and we also saw this in our application, so we are running Java, and there it was a lot of these lines, error while sending response to client, connection reset by peer. So the peer reset the connection. This has to be bad, right? And after hours of digging and reproducing this stuff, we found out that it's a Firefox feature, and it's called Raise Cache with Network. Who of you knows this Firefox feature? Raise your hands. 1. Please keep it up. I can't see it. Yeah, that's 1 geek. 2, 3. Yeah, about the same happened in our company. So Raise Cache with Firework works like with Network in Firefox works like this. If there's a cached resource, an image, something, in our case, a configuration that we, and Firefox takes longer than requests this resource longer than 500 milliseconds after the initial page load, then Firefox decides, okay, this web page is apparently very, very slow. And most probably, it's caused by a slow computer. So a lot of laptops are still running spinning disks. And if it takes longer than 500 milliseconds, you know what I do? I just request the file which should be cached from the local cache, and simultaneously I produce a network request to the original source. And whichever arrives first, I will take. So, that was the first thing that boggled us. Why are these resources even queried in the first place? Because they should be cached on the client, right? We thought we messed up something there. This was the case, and it took us really a long time to get to the point of it. Yeah, and that was what I wanted to mention. Before we enabled HTTP2, there was no way for the client to abort this request except terminating the TCP request, which it wouldn't do. It wouldn't terminate the TCP request. I don't know why. In HTTP2, it could, because it just used the already established stream and immediately sent an abort. The TCP request was still established. Yeah, and that's it. So this was a feature that impacted us because we enabled HTTP2, but was not really related to it. Yeah, quite interesting. So if you see something like this, mind my words. Yeah, and finally, the next challenge, my personal vendetta, crawler protection. So crawlers are bad for us. We are a site, a classified site. We are producing ads for the customers, and sometimes we are not fast enough, but we want to be crawled by Google because they are indexing us and they produce hits. So the crawlers come with a range of varieties. For instance, there's this Google Bing bot mayhem every website has to deal with. But there are also badly written bots. Just 2 weeks ago, we had a student at the university trying some things, and he was producing searches as fast as the network could handle from his mobile device. And it was enough that we really saw him. Yeah, I could tell you a lot of stories in this request. And also, it also impacts our business because it sometimes produces the wrong access numbers. If you want to show how many requests were to your ad, for instance, then yeah, this could be heavily influenced by a crawler as well. So right from the start, we implemented something from a JProxy, which is the targeting functionality. This is quite easy. I really like it. So what it essentially does is you have a blacklist of IP addresses, and if this IP address requests your service, then after a grace period of 10 seconds, it gets a 503 or 502, and it looks like the service is down. Works pretty well, but you have to really take care because it's highly disruptive. You're actually blocking all the requests to your site from a different IP address. And this could be a bad idea if you are running in, so if a company is running a netted network or a web proxy, for instance, then you always see the same IP address. And if it misbehaves and you block the whole range or the whole IP address, then yeah, could lead to bad side effects. Of course, it's also dangerous if you have a dynamic IP pool. Most mobile devices are assigned dynamic IP pools. And yeah, if you blacklist them, it could easily happen that the IP switch and then a new customer suddenly cannot access your site anymore, and you don't know why. So we tried to get away from that and have something less disruptive, and that's where the JProxy Enterprise Edition Antibot module comes in, and that's the main reason why we decided to use the Enterprise Edition in the first place. So, basic idea is quite simple, actually. If a client requests your site, it doesn't get the site, but on the first request gets a JavaScript. It needs to execute the JavaScript. The JavaScript on the client sets a cookie and is redirected to the origin page. And if the cookie is correct, it has to be verified by JProxy, then it gets the original site. It works pretty well. Yeah, it was really easy to implement. There are different strategies how to produce this challenge. So yeah, either it's automated, you can even include Google captchas. Yeah, wide variety of things that you can do. And it looks like this. So sorry, I had to blind the secrets, but yeah. So essentially, all the logic to decide if such a challenge is produced in the first place is in this is contained in a Lua script. So I decided to go Lua there. Most probably you could do most of the things in the configuration itself, but it's pretty nice to have it contained in a Lua script, and then you can code different triggers and stuff. Yeah, so we came up with this. And then the top secret rules are checking if the cookie is correct. And long story short, the user gets a challenge if the Lua script disagrees or the cookie was bad. And that's it. And it works pretty nicely. There are some caveats, some quirks that you have to take care about. For instance, this is very bad for AJAX requests. Because if you're doing an AJAX request and you get a JavaScript challenge, it's usually not solved. Yeah, you have to take care of not messing up your application. Yeah, I'm almost through. No, nothing detailed about the text anymore. So now we are on JProxy Enterprise 1.9.1 release R1, and we're pretty happy with it. Everything is working. Kubernetes is integrated, and I wanted to give you some miscellaneous quirks of what we are doing right now and what gives us thought. So one thing is the balancing algorithms in Kubernetes. So we are using an overlay in Kubernetes, which means all exposed nodes are in every backend that is generated. So it's always the same nodes, and the overlay network takes care on how to distribute it. For this, we used usually we use LeastCon because it's really perfect for Java applications where you have occasionally a garbage collection, and if you use LeastCon as a balancing algorithm, you essentially don't overload. You redistribute during this small hiccups. You redistribute all the requests, and that's simply not possible in Kubernetes anymore. That's why we had to switch Kubernetes to Flannel, which is the overlay network, to LVS. So it supports LVS, and there LeastCon is supported again. Secondly, something I wanted to show you, we just started dynamic environments. So the thought was for every pull request, we wanted to have something like a dynamic environment that can be accessed. So a developer creates a pull request, a complete dynamic environment spawns up, they test it, and if it's okay, the test is okay. If it's merged, then it's torn down again. And we managed to do this with Kubernetes, but what we needed is a URL. And the URL looks something like, sorry, the URLs look something like this. So if you have an URL, a host name that looks like this, and you want to access a backend that looks like this, I knew that this is one of the things that when you know HA proxy, you know that it can do it. It might be a hassle to implement it, but you know it can be done, and that's how I did it. I know maybe it's not beautiful, but it works. So it's Dyna underline, and it takes the host header. So you read it from left to right. It takes the host header, the whole thing, to lowercase, substitute dashes with points, and take the second field, which is the hash, and append it to Kubernetes. Yeah, shame on me. But it works perfectly. I'm really happy with this solution. And now we implemented this dynamic application. The only thing that you have to do is create a wildcard CNAME for the subdomain. So that's everything you have to do, essentially, to get everything to the same IP address and then make this decision. Yeah, that was it. I'm over time, but here are some numbers that I wanted to show you in terms of what we're dealing with. So maybe the most interesting, we do have a peak traffic of 5.1 gigabit for external facing, 5.7 in total, including our internals. So as you see, we are already reaching 10 gig limit, and that's the next thing that we have to think about, maybe distribute it. I don't know how we tackle this, but it's something that will come up in the next year. And I'm sure we are gonna be able to solve it. Yeah, we're dishing out 700, 750 terabytes of traffic in 30 days. And at the moment, we are running 55 backends. More than half of them are generated by Kubernetes. It's going in a microservice direction, yeah, and will be more. And everything is handled with just 14 threads. We had no need to expand this. So we can deal with this traffic easily with 7 cores on peak time. Yeah, for the future, we are really excited about HA Proxy 2.0. And in my opinion, traffic shadowing is the thing that I anticipate the most, because it gives us the opportunity to have production data on a test environment. I mean, how cool is that? Great. Yeah, I won't divulge into the other things because I'm already over time. So thanks for the attention, and if you have questions, I'm happy to answer them.
Okay, thank you so much.
Thanks.